Hey, you going, guys? Michael with you here again, and welcome to the second of my Java VTMs. In this video, we're going to be looking at the primitive data types that are available for us in Java and how we can use variables in our programs. Now, if you're thinking right now, oh my god, he just said the word variables and data types and I don't know what he's talking about, do not panic. This will become very clear to you by the end of this video, hopefully. So, we'll get started straight away. We've got a new file open up in our text editor. First thing we'll do is put a bit of a comment. Primitives.java. This program demonstrates the primitive data types available in Java. That's exactly what we're doing in this video. So we'll continue same as what we did in the last video. We'll have a class, because all our executable code in Java needs to go inside a class. So public class primitives, opening bracket, closing. Now, as a side note, I get into the habit of closing these curly brackets as soon as I open them. The reason for that is if we've got a lot of nested code, it makes it a lot easier. If you've closed these straight away, you won't forget about it later, because otherwise you probably will, and it will bite you in the ass. So, first thing we're going to do, like before, we have a main method. So public static void main string array args, opening curly bracket, closing. Now I just said the word array. That's to do with these square brackets here. We're going to go into the arrays a bit later on, so for now, like last time, just forget about that. Don't worry about it too much. So now we're ready to go. So what do we need to do? Well, up until now, in the last video, all we did was have a simple program that printed out something to the screen. Now, if that's all that we're able to do in our programs, we can't really do anything useful. Sometimes we need to be able to use different data and store that data for later use and be able to manipulate that data. This is where variables come in. A variable is basically something we can use to store a piece of data. So, what I'm talking about when I say data types, there are different types of data that we might want to store. For example, we might want to store integers like numbers. We might want to store characters, things like that. They're different data types. So, we know we want a variable. So, how do we go about using a variable in Java? Well, the first thing we need to do is declare it, okay? And declaring it basically tells Java that we want a piece of memory to store a piece of data. That's all we're doing. So how do we do that? Well, the first thing we do is type what type of the data type that we're going to be using. And just to get started, we'll just go int. I'm going to explain this in just a minute. I just need to get this out of the way first. So int, and then the name of the name that we want to use for the variable. Now, similar to how Java has naming conventions for class and method names, variable names also have a naming convention that we should follow as good programming practice. The idea is that we want to call this variable myInt, by the way. The idea is the first letter, variables always start with a lowercase letter. I can speak this morning, trust me. So we're going to call it myInt, so lowercase my, and then each subsequent word in the variable name starts with a capital letter. So capital I int, semicolon to end the statement. That's it. We've declared a variable. Hooray! What exactly happens? Well, probably the best way to explain this is to do it visually. So I'll just jump over to my super high-end drawing package. By the way, I'm writing this with the mouse, so it might be a little bit messy. So what we've got this line of code: int my int. This is the line of code we just typed. We're declaring a variable. So what actually happens? Well, just picture in your head, we've got this big pile of stuff over here representing the computer's memory. And inside the memory, there's different locations where we can store data. Okay, so I'll just continue. So, the first thing that happens, we've just said what data type we're going to be using, an int. What happens is Java finds a spot in memory that is big enough to store an int variable, and then assigns this memory to our variable name. So, when we use myInt is pointing to some location in memory which can store an integer value. That's awesome, but you'll notice that when we first start, there's nothing really useful to us inside this memory location. How do we get around this? Well, we need to initialize our variable with a value. So we just jump back over to our editor. We give it a value, and how we do that is with the assignment operator, which is the equal sign. So we have the variable name, my int equals, we're assigning it a value, and then we'll just give it a value. This time we'll go 5. What this line of code does is we jump back over to a text editor. It assigns the value of 5 into this memory location. So, like that. So, myInt is pointing to this, which has the value 5 in it. That's what's happening when we assign it to a value. Now, we can just prove this by printing out something cool. So, we'll go system.out.println, and we'll go, with a string, we'll go myInt equals, end the string, and then we go plus myInt. End the parentheses, so we end the parameters, and a semicolon. So what this is going to print out is firstly the string myInt equals, so we'll see that, and then the plus myInt is not really plus like an addition plus, it's a concatenation operator in this case. So the value of myInt will be printed out after this, and we can just save and compile this right now to prove that. So we'll save that, yes, we'll save it in here, we'll call it, remember, primitives.java. It should match the name of the class that we're using, so save that, and we'll jump over to here. We'll compile it, javac, what do I call it, primitives.java. Thinks about it for a minute. There, compiles with no trouble, so we'll run it, java primitives. Oh, we don't need the class, remember, just the name of the program. myInt equals 5. So you can see that the value 5 is being printed, and the value 5 is what we've got stored in myInt. Alright, that's the basics of how we declare and initialize a variable and what a variable actually is, okay? So now, different data types. Well, the first, we've already seen an int, but what exactly is that? An integer, it stores a number, okay? When we're talking about ints though, we're talking about whole numbers, numbers without decimal places. So we can't have something like 5.1 like that. No decimal places, whole numbers only. So things like 32, 961, negative 40,513, okay? Full numbers, this is what we can store in an integer. Now, an integer stores its number in a certain amount of memory. It's not like we've just got this infinite space that we can use to store our variable. In the case of integer, it stores its number in 4 bytes or 32 bits, okay? Now, because of that, it gives us a limit to the maximum size number that we can store. And I can prove this if we jump over to, Javadoc, here we go, Javadoc. There's actually a class in the Java API called integer, and it is alphabetical order, int egg, here we go, integer. There's actually a variable inside integer called max value, and we can use that to find out the maximum number that can be stored in an int. So we do that, just go integer.max value, and now we'll save that and recompile it. I'm pressing up and down here to go between commands I've already entered. So compile it, compile's fine, execute it, and you'll see that this number here is the biggest number that can be stored in an int variable, okay? Well, that's fine, but what if we want to store something really huge? Well, lucky for us, Sun thought about that, so we've got another type of variable called a long, and we'll call this one myLong. Okay, a long integer is exactly what it sounds like. It uses twice as much memory to store the number, so that means it can store a much larger number. How large? Well, if we do a similar thing here, myLong equals, similar to how there's an integer.max value, there's also a long.max value. Long.max value, semicolon, and we'll print this out as well. So copy and paste that. myLong. Oh, I can type myLong. Save that, compile that, and we'll run that. And you can see that a long integer can store a much larger number. It's huge. So there we go. If we need to store a really big number, we use long. If not, we use int. Now, there's also one more type of integer variable, and that is called, similar to how there's a long, there's also a short. myShort. Now, similar to how long is double the memory of what an int is, a short is half, okay? So 16 bits, or 2 bytes. So we can print out the maximum value that a short can have, similar to how we did the other two. Short equals short dot max value. And we can print that out. My short equals my short. Save that. We'll jump back over here, compile it again, and we'll run it. Oh, where's it gone? There we go. And you can see that a short variable can only store a smaller number, 32,767. So there we go. They're the 3 data types we can use in Java when we're talking about whole numbers. Integer. So we'll put a comment here saying what we're doing. Types deal with whole numbers. Okay? So we got int, short, and long for doing this. So, well, that's awesome. But what about if we want to store something with a decimal place? Well, there's 2 data types we can use in Java to do that. The first one we're going to use is called the float. It's a floating point data type. And we'll call this one my float just to be awesome. Okay, and we can assign this with a value with a decimal place. And we'll do that right now. My float equals 123 decimal 456 semicolon. Float. We'll put a bit of a comment here as well. Deal with decimal places. Okay, so that's what we're doing. Oh, wrong. So we can also print this out to the screen. My float and my float. And we'll save that and we'll try and compile it and see what happens. I'll just clear the screen first so we can see this a bit easier. You'll see that we've got a bit of an error. Possible loss of precision. Well, what does that mean? It found a double and it tried to assign that to a float. Well, what is a double? Double is another data type that we can use to store decimal point numbers. Double. And it's used the keyword double, my double. Okay, so what this is, similar to how there's an int and a long, it's kind of the same with float and double. The difference is that double can store, remember, we're dealing with floating point numbers here, so if you remember in high school maths, or if you're doing high school maths, look forward to this, we're dealing here with significant figures, okay? A double can store a number with the 15 significant figures precision. Whereas a float only stores 7 significant figures. So that's the difference between these two. Now, by default, when we're dealing with decimal point numbers like this, Java uses double to represent them because it's got more precision. And then we're trying to assign this double number here to a float data type. So that's why we got this error with possible loss of precision. So what we can do to get around this is simply by putting an F after the number. We'll save that and we'll compile it again. And it compiled with no problem. And we can print this out. As you can see, my float equals 123.456. So what is the difference between a float and a double? Well, I've already said 7 and 15. 7 and 15. So we'll just assign a value to our double. My double equals 1, 2, 3 point, and we'll just put some really huge number here, okay? And then actually what we'll do is copy this number over here. Float. We'll save this and actually before we save it, we'll copy this. My double. Now we'll save it and we'll print out the difference, and we can, when we do this, we'll be able to see the difference between the precision of these 2 data types. So we'll come over here, clear the screen, Java, so we'll compile it and we'll run it. And as you can see, the float data type only stored 123.43456, where the double data type went for another 1, 2, and where am I? 1, 2, 3, 4, 5, 6, 7, 8, 9 extra decimal places, okay? So it's got a much higher precision. So, if we need to store floating a decimal point number, we use float if regular, or we use double if we want a really high precision, okay? That's the two data types that deal with floating point numbers, or numbers with decimal places. So that's awesome. Now we've covered all the different ways we can store numbers using variables in Java. So what's next? Well, in addition to numbers, we can also store characters. So we'll put a comment. This section is going to deal with characters. And how do we store a character? Well, the first thing, the data type we're using is called char. And we'll call this variable my char. So we've declared a char variable. So how do we assign it a value? Now, what is a char, a character to start with? Well, something like A is a character. B is a character, the space is a character, okay? 1 is a character, exclamation mark is a character. These are all different characters that we can store in this variable. So we'll assign it a value. So we go my char equals. Now this is very important. In Java, we store characters using the single quotes to represent them, okay? It's like that. So we can put a character in here like A, and then we can print this out to the screen. My char equals my char. We'll save this and compile it. And we'll run it, and there you go. We can see that the my char variable is storing the character A. Now we can also store the character 1 or any digit, and we compile this, and it compiles fine, it runs, and you can see the character variable is storing the character 1. Note it's not storing the number 1, it's storing the actual character representation of this number, okay? We can also put in here exclamation mark. Okay, so that now it's storing that. Note we can't do something like this. We can't have A, B, C. We can compile this, and I'll just clear the screen. Oh, see, we've got a couple of errors. Unclosed character literal. A character data type only stores one character only, okay? Not a string. Strings are these things here, and we're going to talk about them in a bit more detail later because they're a bit more complicated than these primitive data types. So that's a character. I think we've covered that fairly well, I hope. So anyway, what is next? Well, there's two more primitive data types we want to talk about. The next one we're going to talk about is Boolean. Now, some of you may know, when we're talking about binary, you know how we're talking about ones and zeros. With Boolean data types, we're talking about whether something is true or false, okay? So we declare this using the keyword Boolean, and we'll call this variable myBool. Okay? Now, a Boolean, there's only true or false, so there's two values that it can possibly have. So we can go myBool equals true, or myBool equals false. That's it. They're the two values that we can store in a Boolean data type. Now, right now, you may be thinking, well, what good is a Boolean data type if all it does is true or false? Well, this will become very important a little tiny bit later on when we look at control structures in our program. For now, I just wanted to show you what they are and what they can do, and they'll become very, very, very handy in a later video. So that's a Boolean, and we can print these out as well. myBool. Save that. Come over here and compile it. Compile's fine because we got rid of this character error. Run this, and we can see that myBool equals false. Now, you can see the first thing we did was declare the variable, and then we set myBool equal to true, and then we reassigned it a new value of false. Now, what happens here, if we flip back over to Paint, we can do this with any of our variables as well. So if we assign myInt back to a new value 5, and we run this program, we can see that, we compile it and run it, you can see that myInt prints out 5. What this is happening, well, when we first assigned it a value, we assigned it to this some max value here, then we reassigned it with a new value of 5. What happens is, if we flip back over to Paint, so, where's my eraser? I wish I was using Photoshop or something a little bit better than Paint, but not to worry. Incidentally, I'm actually doing all of these videos using free or open source programs. It's quite crazy what you can do with no money. So at the first assignment was max value, okay, which was 2, 3, whatever it was. Then we get another assignment, myInt equals 5. Now what happens here, this is exactly what happens. Inside this location that myInt is pointing to, Java gets rid of the number that's currently stored in there and assigns the new value of 5, okay? That is exactly what's happening on this line. It's getting reassigned, so this isn't in there anymore, now 5 is. Same as what's going on with our Boolean values. For example, if we comment out this line so it doesn't get executed and save it, and we'll compile it and we'll run it, you can see that myBool equals true because it hasn't been reassigned. That's an important thing I'm glad it's come up. Just letting you know that when we reassign a variable with a new value, the old one just is gone, okay? That's how it works. So, that's Boolean covered pretty well. Boolean is true or false. So what's next? Well, there's one more primitive data type I want to talk about in this video, and it is byte. Byte deals with bytes of data, believe it or not. A byte is exactly what it sounds like. If you've done anything with computers before, you'll have some idea of what a byte is, okay? A byte is just 8 bits. That's all it is. And we declare it in Java using the keyword byte. And we'll give this a name, myByte. Now, we're not going to deal with this too much because we don't use it to begin with, okay? Byte is, because it is just 8 bits, okay, it can represent anything. It might come in handy if you're trying to, say, read some binary file up from your hard disk, and you're writing some filter that manipulates an image, okay? Now, you've got a bitmap file. Now, bitmap files, like for an image like this, isn't stored in a text file like our code, it's stored as binary data. Now, using a byte, we can load up the data. A byte can store 1 byte only. So that's all a byte is, that's all I want to go into right now, because we won't see it for a little while. But just letting you know that it's there. Now, just before we finish up, so far in all these examples, we've been declaring a variable and then assigning a value. And this is alright, it uses 2 lines of code. We can get a little bit tricky and a bit more quick with our code by declaring and assigning this variable at the same time. Okay, now how do we do that? Well, we still need to declare the variable just like before, so we'll use an int because they're easy, okay? Int my new int. And then we just straight away have the assignment operator, so equals, and we'll give this a value 10. Now, what is happening here? Well, Java reads this line of code and goes int and sees the integer data type myNewInt. Oh, okay, he wants an int variable called myNewInt. So what we'll do is we'll go over here and we'll find a spot in memory for this to point to. My writing's getting the better of me. Int. Actually, that's pretty awesome. I'm happy with that. That's good. Okay, so we've got a variable. Now we have a variable called myNewInt that's got a spot in memory that it points to. And then we get the assignment operator straight away. Java sees this and goes, oh, okay, he wants to store the value of 10 into this variable. So we'll put 10 in there. Okay? So it's exactly what's happening up here, but instead we're doing it on 1 line of code. It can save us a little bit of time by shortcutting things a little bit. So that's how we can declare and assign a variable using 1 line of code. With that is pretty much all. Oh, before we do that, we'll just print this to prove that it works. myNewInt. myNewInt. We'll save this and we'll come over here. We'll clear our screen to make it a bit easier to see, and we'll compile it. Compiles with no problems, so that's a good sign. And it runs. We can see that myInt equals 5. Remember, because we reassigned it a value here. Then what have we got? We've got myLong equals this huge number, because that is the maximum value that a long can store. myShort equals 32,767, because that's the maximum number that a short integer can store. We've printed that all out. Then we've got our float and double, which you can see that float has less precision than what the double has. These are, in our code, we're using exactly the same number here, but there's different precision. A character can store one character only. In this case, we've assigned it the character A. And then we've got Boolean, which stores a value of either true or false, okay? Then we've got a new int, which we are declaring and assigning on one line of code. With that, that is all I want to talk about in this video, so thanks a lot.